Welcome. In this video I'm going to show you how you can obtain some different types of means using R. I'm using JupyterLab, but the R code should also work in, for example, RStudio. I'm having R version 4.3 at the moment with these packages already up and running, which are the default packages that come with R usually. When people talk about mean, they usually refer to the arithmetic mean, which is actually one of three so-called Pythagoras means, harmonic and geometric being the other two, because they have a geometry perspective for them. The arithmetic mean is the sum of everything divided by the number of items, but it's also actually the fulcrum or the balancing point of all the data. It's kind of like a social measure. It's what everybody would get if everybody would get the same amount. The harmonic mean deals with ratios, geometric mean with compound interest, and because they often have a big impact based on outliers, some try to counter those outliers by simply removing them, which is then a trimmed, truncated, or Windsor mean as it's called. There's also Winsorized mean that doesn't just remove them but replaces them with the nearest value that wasn't removed. I also came across something known as Olympic mean, which was just removing one maximum and one minimum, and then calculate the arithmetic mean from the rest. And decile mean, which is the average of the 9 deciles, which are actually the quantiles 10% up to 90 and including 90%. I have a whole separate video on quantiles, so if you're interested more in that, watch that one. There's also mid-range, which is the average of the maximum and minimum, and although I'm not going to discuss it here, there's mid-quartile range, which kind of counters the outliers effect from the mid-range by taking the mid-quartile range, so from the third and the first quartile, the average of those two. Alright, to show you how this can be done, I need some example dates. I'm going to be loading General Social Survey from 2012, adjusted for some example purposes. I don't need all the data, I just need one numeric field, so I'm going to be using age. I'm removing from the age immediately the missing values. There was one that was actually 89 or older as a category, so I'm just going to replace those with 89 and make sure everything is numeric. I have a separate video on where I show you how you can do it with my own library, which just has a function with all the different means in there. But in this video I'll show you some other options. So the arithmetic mean is actually available immediately with R. There's a mean function and it calculates the arithmetic mean. It can actually also calculate a trimmed mean by just setting a trim proportion. So here I'm setting it to 0.1 and this is therefore the trimmed mean or truncated mean. The Winsorized mean I couldn't find in R's course library, so you could use desk tools. They actually have a function called Winsorize that winsorizes the data. You set the proportion to trim from each side or that you want to replace, and then just average those. So there we go. If you don't set the proportions, it uses, I think, 5% from each side, so that's why this one is then slightly different. It also actually has a function for the geometric mean and the harmonic mean. The psych library has the same three, just differently called, so if I load that one in, I can calculate the geometric mean, the harmonic mean, and the Winsorized mean. If you don't want to use libraries, that's okay. We can, of course, get the length, the number of samples or scores we have. Well, the arithmetic mean we don't need to discuss because it was already available in R. This is the formula for the harmonic mean. So 1 divided by each score, sum all of that up, and all of that gets divided, the sample size gets divided by all of that. The geometric mean, there are a few different ways of writing it down, but this is one that's quite convenient. Although it looks scary, this is just the exponential, the Euler number raised to 1 over n times the sum of the natural logarithm, which is the log function in R. So immediately we have everything we need. The mid-range is the minimum plus the maximum divided by 2, so use the min and the max function from R. The Olympic mean is actually we take the sum of everything, we subtract the minimum and the maximum, therefore we have 2 scores less, so we divide by n minus 2. The trimmed mean was already available in R, so we can just use the mean function for that. The most tricky one is probably the Winsorized mean. For that we use this complicated looking formula. We look at the number that is trimmed, so that's in this case 10% of the total sample size, and we round that number down. Then we sort the data, and then we just fill out this formula, which is that NL times, so that's over here, times the x values at NL plus 1 plus n minus NL, and then the sum of all of that, and divide everything in the end by n, and we get the same result as we saw earlier, as we saw with my own library. The decile mean is the average of the 9 deciles. So luckily R actually has a quantile function. This I can actually remove because this was for when I did this video with Python. So we can just use the quantile function of the scale fields. We feed it the 9 different deciles. I'm using method 7. There are quite a lot of different quantile methods, so check out my video on quantiles if you want to see more on that. And that's it. I hope this video was helpful, and thank you for watching.